In this video, we'll talk about how to convert polar coordinates to rectangular coordinates. So before we work through a few examples, let's just get an idea of what polar and rectangular coordinates are. So if we're given a rectangular coordinates, that means we're given an x and a y. So for example, let's say we're given a 3 and a 5. That's pretty easy to plot. We just go 1, 2, 3 to the right of the origin and 1, 2, 3, 4, 5 up. So here's the point 3, 5. That's rectangular coordinates. But another way to reach this point is to use something known as polar coordinates. And that's where we're given a radius, so the distance from the origin to this point right here, we can call that r. Because if we imagine that we had some circle like this r would represent the radius of the circle. And if we're given a theta, so an angle from this x-axis right here, we could use r and theta to also arrive at some point. So instead of x and y, if we were given r and theta, we could arrive at the same point. Now, the question becomes, if we're given r and theta, how could we convert these polar coordinates into x and y coordinates, or rectangular coordinates? Well, if we imagine that this forms a little triangle right here, a right triangle, this distance right here of the triangle is x, and this vertical distance is y. And what we'll notice is that the cosine of theta, so that's the adjacent side over the hypotenuse, which is x over r. The cosine of theta must be equal to x over r. So to solve for x, we could multiply both sides by r. And we would find that x, the r's would cancel out over here, x is equal to r times the cosine of theta. Similarly, notice that the sine of this angle, so the sine of theta, let's say, is equal to the opposite side of the triangle over the hypotenuse, or y over r. And similarly, we could solve for y by multiplying both sides by r. So we would get, these r's would cancel out, y is equal to r times the sine of theta. So if we're given polar coordinates of r and theta, we can convert them into rectangular coordinates of x and y by using these two equations. So let's work through a few examples and let's see how we can use these equations to actually convert polar coordinates to rectangular coordinates. Okay, let's say we're given the polar coordinates 4, pi over 3. The 4 is the r, or the radius. The pi over 3 is the theta, or the angle. How can we convert these coordinates into xy coordinates, or rectangular coordinates? Well, we can just use these two formulas that we just derived. So we can say x is equal to r is 4, times the cosine of theta. Theta is pi over 3. What is the cosine of pi over 3? Well, if you think about your unit circle, and we have some angle pi over 3, the xy coordinates that correspond to pi over 3 are 1/2, square root 3 over 2, where the cosine corresponds to this value and the sine corresponds to this value. So the cosine of pi over 3 is just 1/2. So we can write x is equal to 4 times 1/2. And 4 times 1/2, that's just 2. Similarly, for y, we can say y is equal to r, so r is 4, times the sine of theta, or the sine of pi over 3. So we just said the sine of pi over 3 is square root 3 over 2. So we get 4 times the square root of 3 over 2. So if we multiply these, the 4 and the 2 can be reduced to a 2 and a 1, so we just get 2 root 3. So that's our y value. So our xy value, so we can write this as 2, 2 root 3. This is how we can write the polar coordinates and rectangular coordinates instead. Okay, let's try another one. Let's say we're given the polar coordinates -6, pi over 6. So -6 is our r, pi over 6 is our theta. How can we convert these to rectangular coordinates? Well, once again, we'll use these two equations. So we'll say x is equal to r, which is -6, times the cosine of pi over 6. So what is the cosine of pi over 6? Well, once again, if you think about your unit circle, an angle of pi over 6 has the coordinates square root 3 over 2, comma 1/2, where root 3 over 2 corresponds to cosine and 1/2 corresponds to sine. So the cosine of pi over 6 is square root of 3 over 2. So we can say x is equal to negative 6 times root 3 over 2. Now when we multiply these, the negative 6 becomes a negative 3, and the 2 reduces to a 1. So we're left with negative 3 root 3. Now for the y, we're going to use this formula, r times the sine of theta. So we'll say y is equal to r, which is negative 6, times the sine of pi over 6. And we just said the sine of pi over 6 is actually just 1/2. So we can say y is equal to negative 6 times 1/2, and that's negative 3. So we found our x and we found our y. So our polar coordinates in rectangular coordinate form can be written like this: negative 3 root 3, comma, negative 3. That is our final answer. Okay, let's try one more example. Let's say we're given the polar coordinates 8, comma, negative pi over 4. How can we write these in rectangular coordinates? So we'll start with the x. We'll say x is equal to r is 8, times the cosine of theta. In this case, theta is negative pi over 4. So what is the cosine of negative pi over 4? Well, if we think about our unit circle, the coordinates of pi over 4 are square root of 2 over 2, comma, square root of 2 over 2. Now, if we were going to use negative pi over 4, instead of rotating the angle up like this, we actually have to rotate in this direction. So negative pi over 4 would be over here. And it would have the same coordinates for the x because x is still positive. It's still going in the right. So it's still positive root 2 over 2. But the y value is now negative since we're below the x-axis. So this would be negative root 2 over 2. And remember, this corresponds to cosine, and this value corresponds to sine. So the cosine of negative pi over 4 turns out to be root 2 over 2. So we can write x is equal to 8 times root 2 over 2. And when we multiply these two values, this 8 will become a 4. This 2 can be reduced to a 1, so we'll just get 4 root 2. Now for the y, we'll say y is equal to r, remember r is 8, times the sine of theta. So the sine of negative pi over 4. And we just said that the sine of negative pi over 4 is negative root 2 over 2. So we can write y is equal to 8 times negative root 2 over 2. And when we multiply these values, the 8 can be reduced to a 4, and the 2 can be reduced to a 1. So we get 4 times negative root 2. So we'll write negative 4 root 2. So we found our x value, and we found our y value. So we can write our rectangular coordinates as 4 root 2, comma, negative 4 root 2. And that will be our final answer.